Okay, in this video lesson, we'll be looking at reference angles. So what are reference angles? Reference angle, for any given angle, for a given angle in standard position, it's the positive acute angle formed by the x-axis and the terminal side of the given angle. Sounds like a lot, but let's look back. We start with an angle in standard position. Every angle in standard position does have a reference angle. The reference angle is the angle that's made between the terminal side of the original angle and the x-axis. Reference angles, by definition, always have a measure such that theta is some number between 0 and 90 inclusive. So we actually could include the 0 and 90. Or if it was radians, it's a number between 0 pi and pi over 2, also inclusive. What I have here is something to kind of illustrate what's going on. So we have two angles. Here in black is the angle in standard position. There's the x-axis, there's the terminal side, so it's in standard position. The reference angle is in blue. There's the terminal side and the x-axis. So the angle formed between the terminal side and the x-axis is your reference angle. So as I move this around, it starts to illustrate what happens, what we're actually looking at when we're looking at reference angle. So here's my x-axis. I'm in quadrant 2. The closest angle, or the closest, smallest angle between the terminal side and the x-axis is right here. But as soon as it goes in quadrant 3, it's the same x-axis. There's my terminal side. When I move to quadrant 4, the reference angle is over here between the x-axis and the terminal side. So as you begin to see that no matter where I go, the measurement will always be somewhere between 0 and 90 degrees. So here, the highest it can be, if I get it, 90 degrees. The lowest it can be, 0. So now how big the standard angle is, notice the reference angle stays a value between 0 and 90 degrees. If I go in a negative direction, notice the reference angle always stays positive no matter what, because the reference angle is purely asking for how far are you away from the x-axis. So no matter how big the negative angle is, the reference angle is always a positive value between 0 and 90 degrees inclusive. So let's go back. Here's another example. So there's my angle in standard position. There's the terminal side and the x-axis, so there's my reference angle. There's the angle in standard position, terminal side, x-axis, so here's where our reference angle is. Standard position angle, terminal side, x-axis, there's the reference angle. Standard position, terminal side, x-axis, there's the reference angle. So, how do we find reference angles? Well, if it's in degrees, you simply add or subtract 180 degrees until the answer is between 0 and 90 degrees inclusive, meaning we could be either 0 or 90. If it was radians, we had to subtract 1 pi, until the answer is between 0 pi and pi over 2 inclusive. Last thing, reference angles are always positive and acute. And I put acute in quotes because acute technically means between 0 and 90. Here we can actually include the 0 or the 90. So we do a couple examples. So it says find the reference angle. Well, again, the reference angle is between the terminal side and the x-axis. So that's the portion we're focused in on. So we simply start subtracting 180 until we get to a value between 0 and 90. There we go. 30 degrees is our reference angle. And if you look at this little pink region, it does look to be about 30 degrees. Next problem. 615 degrees. There's our terminal side and x-axis, so there's the portion we're focused on. So 615, and we start subtracting 180 until we get to that value we're looking for. Eventually we get to 75. And that looks to be about a 75-degree angle. It's kind of large. 75 degrees is the reference angle. All right, now a negative angle. Nothing changes though. There's the terminal side, there's the x-axis, there's our reference angle. So in this case, we'll start adding 180 over and over and over until we get to a value that's between 0 and 90. 65 degrees is our reference angle. One last one, at least for degrees, and I'll do some radians. Same scenario. There's a terminal side, x-axis, there's the angle. Before we do it, if I was to ask you about how big is that angle, you might say something like 30, 40 degrees, 50 degrees, 60 degrees. Every answer you just, at least that I just said, was a positive value. You'll see why I'm saying that shortly. So let's take out 315 and start subtracting 180s. We get 135, not small enough. Subtract 180. We get a negative 45. And recognize, well, if I continue to subtract, it's going to continue to get worse and worse. So we're going to stop here. What this negative 45 is telling us is that this angle is opening in a clockwise direction, hence the negative. Again, the calculator doesn't know we're looking for reference angles. So it's only going to do the arithmetic. You have to work in concert with it and understand that this is where I stop. So, and you understand that reference angles have to be positive and acute. So you just simply change the sign. Size of this angle, 45 degrees. So you have to be careful as you work in concert, in conjunction with the calculator. If you understand the number is where you need to be, you just change the sign. Alrighty, so let's go to radians. When dealing with radians, my recommendation is to divide and work with decimals, because you're supposed to find a value between 0 pi and pi over 2. Fractions aren't the easiest thing to kind of comprehend if it's between 0 and pi over 2. But if you were working with decimals, it's a little easier. So instead of 0 pi, pi over 2, as a decimal between 0 pi and 0.5 pi. Well, because we were working with the calculator, we're just looking for a number between 0 and 0.5. When it was degrees, we were looking for a number between 0 and 90. So if I use the calculator, I'm simply gonna, well, there's my terminal and my x-axis. So there is the angle we're looking for. So into the calculator, negative 29 divided by 18. So this gives me something to work with. I'm going to start adding by ones, because we're supposed to add or subtract by 1 pi until we get to this value. So if I continue to add by ones, I know my goal is to get a number between 0 and 0.5. So I add 1, almost there. Add 1 again, there we are. There's a number between 0 and 0.5. So now I simply tell the calculator to convert that to a fraction, 7 over 18, which means our answer is 7 pi over 18. I'll go to the calculator to demonstrate what just happened. Start. There we go. And the values we had were 29 over 18. All right, back to 29 over 18. So negative, 29 divided by 18. There's that decimal that I saw. Now I'm just only going to start adding by 1. Plus 1, almost there, plus 1. There's our value between 0 and 0.5. So now I simply tell the calculator, convert to a fraction, which is this button right here. As soon as I press it, there's my fractional value, 7 pi over 18. Or, because we're working with decimals, there's actually an easier way. Once we divide the two numbers, if I understand my goal is to make this a number between 0 and zero point 0.5, I understand adding 1 won't be sufficient. So if I add 2 in one keystroke, there goes the value I'm looking for. All right. Now I want to look at why this should be a reasonable answer. If I compare the original angle to the reference angle, it makes the entire circle. The entire circle is 2 pi. 2 pi is the exact same thing as 36 over 18. 36 pi over 18. Why did I choose these numbers? Because my original denominator is 18. And if I look at the two values, what's in blue is 29 over 18. What's in red is 7 over 18. If I add those two together, it does give me 36 pi over 18. Just to illustrate why this is a reasonable answer. All right, one last one. So we got our terminal side and our x-axis. This is the portion we're looking for. So we'll divide. 34 divided by 9, 3.7 repeating. So I'll start subtracting. Subtracting 1, 2.7 repeating. Subtract another one. Still not good enough. Subtract another. We're getting close now because we got to get between 0 and 0.5. Subtract one more. Bam. There's our value. So like we saw before, it's always going to be positive. So tell the calculator to convert it to a fraction. It says 2/9. Final answer, 2 pi over 9. Or, again, because we're dividing, there's my 3.7 repeating. I understand. I could subtract 1 over and over and over. If I subtract 3, that won't quite be where I need to be. So if I simply subtract 4, which is all of these ones, subtract 4 in one keystroke, there's our value. Okie doke, so hopefully this helps with some of the practice.